Algebra 2A, Unit 4, I think third day, moving towards assessment. Word problems, inequalities, system of inequalities. If you're asked a question for the number of solutions, and there's no pictures around, they just give you two equations. There's a way to check in your calculator. When you put in your calculator the y equals for the first equation and the y equals for the second equation, normally I have you go to blue button table to get the table so you can graph it. Well, one of the questions, or three of the questions on the test, they don't ask you to graph. They just want the solution and you give the answer, 2, 3, 1, 4, whatever it is. Then they ask you something like, hey, how many solutions are there? Now you might be kind of like, well, one, the answer I just gave you. But it turns out you need to hit the graph button to see what it is. Like if you hit the graph button there's a problem where they say how many solutions, and you see it crisscross once. In addition to whatever your answer is, I'm saying 2, 3, I'm just making that up. You'll put one solution. Okay. You hit the graph button, and you see two lines parallel to each other. You can put no solutions. They don't crisscross anywhere. I did see somebody's test where I know one of the answers is probably going to be this, because they want to do one of all three, but they had an answer for all three of them. I was like, you're going to need to hit the graph button. And then the last one, if you hit the graph button and only one line shows up, which is going to be weird, because there are two equations, they have to be two pictures. Chances are they're resting on top of each other, in which case it's going to be an infinite number of solutions. In other words, 2, 3, 3, 4, 4, 5. Any answer will work. So that's just a note. For video recap, you got 3 problems. Once you put it in the calculator and go to the table to get these problems, hit the graph button. If you get parallel lines, there's no solution. They're going to ask you how many solutions are there. If it's crisscrosses, there's one solution, and you should be able to find out what that number is by looking at the table. It's the line where the x has 2 y that are exactly the same numbers. If you hit the graph button, which you should, and there's only a single line, chances are, if you put in 2 equations, they are resting right on top of each other, and it's an infinite number of solutions. In other words, you can do 2, 3, 3, 4, 4, 5, and so on. All right, to solve for x, what do we want to do? To solve for x, first we got to get x out of the house. Anybody know what you do to get an x out of a house? Or how do you get rid of a house? What's the inverse? Good, good, good. That means I'm teaching you. You don't already know it, which is a good thing. Otherwise, they'd fire me. Like, what? The kids already know all the stuff you're teaching? Yeah, well, what do we need you for? To square something is the opposite of a radical. What you do to one side, the green stuff, you must do to the other side. This is why this one's going to be a hard one. We'll use the quadratic formula on it. Here it comes. Next row, 5x plus 6. They undo each other, a house and a 2, so that just comes out. Over here, we do have to square you. You do become a 4, and you become an x squared. In other words, the exponent outside hits the 2, and it hits the x, not just the x. Take a look at that. Make sure. All right, here we go. Step 2. The side that has the positive coefficient in front of the square. In other words, technically I could move this 4x to this side. Why would Thomas choose not to do that? Because it'll make the 4 a negative 4x. And when you're dealing with the square term, usually you want it to be positive. So I'm going to move all these other guys, these lesser guys, over. In other words, the 4x squared is the big brother. These two guys here, they're the younger brother and sister. So you got to go where big brother is. In other words, you're going to be left with a 0 on the side. Everything's gone. Equals 4x here, the good. These two guys show up on the other side, same numbers, but the opposite sign. The plus 5 becomes a minus 5. Anything yet? Or no? He's waiting, he's thinking, it's going to the computer. Come on. Oh, okay. Yeah, if you need to get another one, grab another one. They've been pretty slow. Hopefully it won't be the way. Once you get them over here, I'm not dividing, I'm just putting, I guess I should make a little round. To do the quadratic formula, you need an A, which is always the number in front of the square term. You need B, the number in front of the regular x term. And then C is the number just by itself. It includes whatever sign is in front of it. So I don't know when you saw the quadratic formula, but you had to see it some time ago. I don't know if you did in this class because I don't remember, but here it comes. There's a bad boy. He was unsure whether he'd go to this house party. When he got to the party, because there's so much drugs, he felt like a square. A square is like a good guy. And so he missed out on 4 awesome chicks. Those are women. And the party was all over at 2 a.m. All right, that's the way I heard it. Go with that. We're going to plug in these numbers into here. You work it out, you win. X equals this, X equals that. For this thing here, when you write the version below it, we're actually putting stuff. Because there's so many places to mess up, I will give you most of the credit if this next line is correct. If this next line is incorrect, for sure you're not getting more than half. What does he mean next line is correct? That is, on this next line, put in parentheses for the B. Another parenthesis for all the letters that you're going to plug in, I want a parenthesis there. There's a reason for it, because when they're negative numbers, some students don't know how to handle negative numbers. But by just putting the parentheses, it shows me that at least for the A and the C, they get their own little rooms, that you're going to put things in where they go. What if you're super duper, you're genius, you don't need to do it? Okay, you can chance it. I'm not mad at you. You did this in 7th grade or whatever, did in 8th grade, 9th grade, and so on. There should be one right there. You can grab that one. You can use that guy. All right. So why is this important? Because when it's time to put numbers in, let's say like this B, because it's a -5, some people are just going to make it a -5. Negative B, -5, duh, that's a -5. But if you put the whole -5 inside there, then ultimately it will turn out to be a +5. But for now, just putting things where they go, I want to give you like half the credit. Let's see, let me put my letters on the side so I can see them. A is a 4, B is a -5, and C is a -6. All right, B, you're -5. A, you're a 4. That's why they call this random review. I expect you've seen this somewhere. C, you're a -6. This part here is getting you half the credit if you have the right numbers in the right place, and C, you're a -6. But you're supposed to be an A, so I'm going to rewind you and make you a 4. Pause and pause it, let you take a look. That's where, why is that going? This piece right here is where students make their mistake. Here's a little bit of advice. When you multiply the 4 times something, yes, it's -4. This becomes a -4 when you're multiplying it times the family. The other piece of advice is, if there are only 2 negatives, this whole section will become a plus something, positive something. If the 4 in the middle happen to be a negative, you have 3 negatives, then of course the whole thing would be a negative. All right, let me try and finish this guy off without much more, because he's the past, you need the future. All right, I'm going to stop here at +5. You'll have to finish the rest. 25, any number squared becomes positive. This is going to be plus something, 16 times 6. Anybody get an answer for what 16 times 6 is? 96. All right, and that's a plus 96 all over 8. Hey, what do you have to do? You have to add 25 to 96. Find out what that is. Take the square root of it, and then for your final answer, sure, I'll just do it. 5 plus or minus. What's 25 plus 96? Is 120. Oh, good. Which of course is going to turn into an 11 when we do the square root of that. Which gives us 2 answers. 5 plus 11 is a 16 over an 8. And he's what, a 6 over 8? No, you're 6 over 8. So 1 can stay as a fraction unless you want to just do both of them, which will be 0.75 if you're using a calculator. If you're not using a calculator, you just reduce the fraction. Pause. I'm going to erase B. For B, we got to get to the x's. How do we get to the x? We got to get them out of that house. How do we get them out of that house? We're going to multiply by a 3. Like, why is it multiplying by a 3? He doesn't want a fraction anymore like that. So let's see if they can handle this. Step 1. Whatever the denominator is that's in the problem, can I highlight you? Whatever the denominator is in the problem, that's no good. We will, we're going to use that number on the outside. Here's what I mean. I'm going to put a 3. Can I just put a 3 there? I can't just put a 3 there. That's illegal. Fine. Fine. Let's get rid of this 12 first. Minus 12, minus 12. Leaves with the minus 2x, 3 plus x equals 7 minus 12 is a negative 5. All right, what you gonna do next? Divide by negative on both sides. That's crazy. Multiply by 3 on both sides. That's ugly. Divide by 1. Shoot. To get rid of this 1 out front. All right, which leaves me on the inside with a 2x over 3. I'll leave it in parentheses. And an x equals a positive 5. Yeah, they're going to miss points on this. Do work, as much work, show work. Somewhere in there, you're going to miss one piece. You get half for trying, and I'll circle where you made a mistake. Last part, how do I get rid of this 3? I want to get to the x's. I'm going to multiply a 3 on this side and a 3 on this side. Why is he multiplying a 3? He's trying to get rid of the fraction. He knows when he does 3 times the first piece, the 3 is going to cancel, leaving just the 2x. And when he multiplies the 3 times that one, he's going to get a 3x. The other side, oh yeah, this is a mess. The other side is going to get a 15. Look at that. Shoot. Now, if you make it here, I almost want to just give you credit for already adding 2 plus 3, making it a 5, dividing into a 15, getting a 3. So if you get here, if there are 4 points available, you got 3 of them. Even if you mess up right after this point. Here it comes. 2 plus 3 is a 5. I'll say the long version of it. I'm gonna finish this piece here, and then I'll say the long version of that. I'm gonna divide 5 on both sides. Equals a 3. Good question. There's an answer there. I'm gonna respond to that probably offline. No, I'll respond to online. That is, hey, there was a red 3 out front. Now down here, there's just a 2x and no green 3. There's 2 ways to think of it. This 3 is being multiplied inside 3 times 2 is a 6. 6 divided by 3 is a 2. There's one way of saying it. 3 times x is a 3x. The other way of thinking of it is these 3's are going to cancel. 3 goes in, 3 goes into 3, 3 goes into 3. But for a student who might want to see what happened right here, 3 times 2 is a 6x all over that green 3. And then 6 divided by 3 is a 2. Make them red so you can match his friend there. A 2x, which is what goes there. Let's pause that for a second so that you can look at it for a second. Do some final answer there. And you know someone's going to die at the end. It's a spoiler. You know they're going to die at the end. Then it might be interesting to see how they got there to their death. Apparently, Quentin Tarantino likes to do this. He likes to show you kind of the end. And he backs up and tells you how he got there. He's into the violence as an artistic expression as opposed to just violence for violence sake. So here's the deal. If you look at problem 3A through C, A through D, no, it's A through C, they're going to end like problem 2. So there's going to be an X, there's going to be a number. You're going to have to put a dot at that number on a number line. Oh, is it a 3? Okay, it's a 3. I'm going to find a 3 on the number line. I'm going to put a dot there. Sometimes it'll be colored in if there's an extra thing like greater than or equal to, less than or equal to. Sometimes it'll be an open circle if it's just greater than or less than. No extra piece, no coloring. Okay? This is how the movie's going to end. Once you get here to the end of the movie where there's an X on the left and a number on the right, the question is, how do I draw the picture? for this? The answer is, if I were drawing these, which I'm going to draw a super small version of them, small version, small version, small version, small version. This is a number line that I'm drawing a super small version. They did a good looking version. No, I'm doing a small version. I'm going to do mine in green, which is the correct answer. These are out of order, but these will be in order. In other words, hey, Thomas, how do you graph x is greater than 3? Well, on my number line, I put the number 3, and then I draw a circle there. Hey, Thomas, how do you graph x is less than 3? I draw a number line with a 3, and I put a circle right there. Hey, don't you need like a 4 and 5? Yeah. But this is enough where if I put this on a test, I'm half right already. I do this guy, yes, the same 3. How about the last guy? Same 3. I just drew 4 number lines. Next thing to get you more than at least half of the points, you have to draw an arrow, a red arrow in some direction. How do you know what direction you're drawing the arrow in? Whatever the symbol is in the middle, make that the tip of your arrow. He's pointing to the right. This guy, he's pointing to the left. This guy is pointing to the right. The tip of my arrow has to match what's in between. And my friend here is pointing to the left. I'm almost finished. So step 1, fake number line, whatever number they have, you put it under a mark. Draw a circle, circle. Arrow to the right, arrow to the left. Last thing, some of these are going to get colored in, some are not. You have that extra line. The extra line is like a crayon to color in the circle. Extra line is like a crayon to color in the circle. No extra line, no color. No extra line, no color. These are the correct answers for each one of these. So let's see. So the real answer over here with the 3 colored in. Oh, top row, he's good. How about this guy? He is down here. So the 4th guy. Let's see if I can do it by getting some fake letters. Let's say if your problem A, B, C, D. A goes with A. You're good. B, you actually go with. C, are you with your partner? Yeah. And then D. Let's see if we can view this problem for a moment. This part is actually really important. Whenever you see X, you use the phrase all numbers. All numbers that are greater than or equal to 3. Everyone has to give an answer. I'll do the first one, then everyone has to give an answer. Hey, Thomas, what are all the numbers that are greater than or equal to 3? I'm going to choose 17. Okay. Marcos, what's another number that's greater than or equal to 3? I chose 17. 17 is greater than 3, so it qualifies. 8 will do. David?
9.
9. 4. 6. All right. The last one I'm going to add in there is 3 is also greater than or equal to 3. That greater than or equal to is why we color it in. Here we're saying that the number 3 is part of the solution. It's one of the choices we have. Let's do this next line for this guy here. Yeah, let's do C so you can feel the difference. Hey, Thomas, what are all the numbers that are bigger than 3? No, you only can be equal to 3. The minute you get bigger than 3, then you're a solution. I'll do one. 2017. What's another solution for this problem? Number bigger than 3. 16. 30. Here comes another question I'm going to ask you. By the way, how many answers are there that will solve this inequality that is a solution that if I put it in, that number would be bigger than 3? How many answers are there? We did 5. It's an infinite number. In other words, this arrow says all the numbers down this way, 4,000, 1 million, 2 billion, 45, all these numbers down here qualify, and they're infinite. They go on for infinity. So it's an infinite number of solutions. Here comes the question. Is 3 one of the solutions? No. 3 is not. In other words, 3 is not a number that's greater than 3. It's equal to it, but it's not greater than. And when you are not one of the answers, you have to have that open circle that shows like you don't belong. So 3 don't belong here. What are all the numbers that are less than 3? Oh, negative, or 2, negative 1 million, but definitely not 3. So that's what the circle thing. So what's the vocabulary they have? How many solutions? Okay, they know there's an infinite amount if there's an arrow involved. Oh, I need the name of the actual number. The 3 is called the boundary point. That's the point, the point between the answers and not the answers. It's the boundary point. So 3 is the boundary point in this problem. All the numbers to the right here are the answers. All the numbers to the left, boundary point. All right, let me see if I can solve a couple of these, and then we'll get it back to this. The good news for some of you is these are solved just like an equation. If this were an equal sign, you do it exactly the same way. It will let me. I'm going to subtract a 4 and divide a 3. Over here, I'm going to add a 3 and divide a 4. Here, I got to do some extra stuff. So I'll do one of these. So let's find out which one they want. Well, no, they're both that easy. Let's do them really fast. And then get down to one that's real and his friend who's a little trickier. But these are free problems on the test because they'll give you at least 1 or 2 of the babies. Here it comes. I'm going to subtract the 4. This thing just comes out like an equal sign, doesn't change. It only changes if you divide by a negative. Divide by a negative, it has to flip. 13, what are you, or 9? Hopefully they can see that when I divide a 3 on both sides, I'm going to wind up with x less than or equal to a 3. Hey, Thomas, which one of these is 3? Whichever one you want. You can label 1, 2, 3, or you can do what we mathematicians do. We choose one. You get to be 3. You put a circle at 3. Picture in the middle, goes that way. 3 is part of the solution. That is has an extra line. Take a look at this, see if you're confused. While you're looking at that one, I'm going to do this one. You don't have to write the second one unless you want to print this paper as one of your 6 pages. Then you can. Plus 3 on both sides. For x greater than 10. Ooh, he's going to be ugly because he's going to be a decimal. But whatever. I have a calculator. 16? Good, good. Yes, I messed up. I'm glad I did because we don't want a decimal. 16 and a 4. Hey, what are all the numbers that are greater than or equal to 4? Is the question. Well, I know if I had 4, let me just mess with them so they'd be like, why do you put it down there? Put the 4 all the way down at the end, just to show it doesn't matter where you put it on the number line, as long as it's in the right. As long as if you put in any of the other numbers, they'd be the correct numbers. Slow, 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 slow. Circle at 4. Tip points that way. Tip of my arrow points that way. Color it in. Take a look. See your question. Your friend down here, he's gonna be tricky. Your friend down here, you just gotta solve, but that's the gist on the test. All right. So, please say again. Oh, does he? D is weird because we have to do it twice. Now I've forgotten one piece that's gonna mess us up, but I'll do it twice and see if it gives me the answer that I would get if I only did it once. Let me do my friend here on C, and then this one looks weird. I think they do something like that on there. Now here we go. 3 and 2 is a 3x and a 6. 5x and a 2. I'm going to move the x's to the right and the regular numbers to the left, leaving me with a 5x, a 3, the greater than symbol that didn't move, the 6 that was already there, and the 2 that I threw over. When you move things back and forth, it's always the same number for that 2, but the opposite sign, the same number for the 3, but the opposite sign. I wind up here with a 5 take away 3 to be a 2x, way too fast, and that becomes an 8. I'm running out of space, but I know I'm going to wind up with x. It's going to be greater than a 4. Hence the negative over there, but I think I have to do it twice. I'll put it over here so they see it doesn't matter. I'm going to put the 4 here at the very end. I see nowhere to put it. You can put your own numbers on the number line. 4, 5, 6, 7, 8, 9, but it's only the number in the problem that matters. You're going to point this way, you're empty because you didn't have the extra piece. Look at it, see what it means to you. While you're looking at that one,
Pretty sure it's throw shape.
throw shade, done and done. All right, here it comes. To do this problem, if you do an absolute value, it's two problems in one. There's a positive version and there's a negative version. Here comes the positive version. You just rewrite things like most students do, which is they get half the credit by accident just because they know, well, I'm going to add 3 on both sides. Here is the other version. I wish I had a different color. INEQUALITIES going to get a different color. Yeah. But don't do it yet. Do it black first. So you can see that x minus 3 stays the same. The second version is where the 5 becomes a negative. Hey, why do you do 5 as a negative? Because your teacher says so. I'm sure there's some real reason for somewhere. I sort of know it. Not only is the 5 negative, but if it's an inequality, you also have to change the direction of that guy. Once you do that, then you'll solve it like a regular problem, and it will spit out 2 answers. We'll see how they show up on the number line. I thought we'd do better than it's doing. In any case, here we go. We're gonna plus 3 on both sides, and blue, and red, and green. How about green? Let's plus 3 in green, or red. Plus 3 in green. Now it's in 3D. Hopefully you bought your 3D glasses. I think I've seen a movie in 3D. Whatever it wasn't worth it. I think it's an extra $3 or whatever for 3D. Again?
I don't think 2 weeks.
You got 5. All right. Turns out 3D is just the studios making extra money. The amount it costs them to make those glasses versus how much extra they can charge you, -2, to watch their movie. Some of which, like, come on. You didn't even do any real 3D stuff on this movie. You just sold it. Yeah. By the way, if you're watching a 3D movie and you decide at some point, like early on though, first how to do that type of problem. And an absolute value problem has 2 setups. You have to do the regular, the black. You have to do the version where you change the 5 to the opposite. When you do that, you also change the symbol. So it's just what you do. Now, there's a reason for it, but half of those reason whys in math are not even worth hearing. It does have to do with the absolute value, where the absolute value of any number is positive. In other words, if I had the absolute value of 5, I'll make it 5 just so it semi-connects. The absolute value of a regular 5. Both these answers are 5. The absolute value does something where you can have 2 different numbers that gives you an answer. Because of that, when you're solving an equation with it, you have to do 2 versions of it, a positive and a negative version of it. There's a reason for it, but those are the steps. All right. Last piece that I'm trying to get to. Again, 4 is called a boundary point. It's the point that separates the answers from the non-answer, solution from the answer, non-answer. Okay. All right. Let your brain relax for a moment. See if there's something you want to ask about those. I'll pause. Look at it for 15 seconds. Where'd you get this? Where'd you get that? Are those arrows really kissing? Got the last piece of the puzzle. Last piece of the puzzle is word problems. Go. Okay, the cost of a burrito at Patricia's Mexican restaurant is $2.35 more than a large taco. Vanessa bought 4 burritos and a large taco for a total of $20.65. What is the price of each item? Oh, I hate this. Well, here we go. I know some of the steps to them. Step 1, whatever the 2 things they're talking about, give them a name. Usually use the first letter in the name. So we're talking about burritos and we're talking about tacos. All right, let's see what they're saying about tacos. The cost of a burrito at Patricia's Mexican restaurant is $2.35 more than a large taco. Well, how much is the taco? I don't know. That's why I put a letter T. How do I write out that first sentence? The cost of that is whatever. The cost of that. The cost of what? The cost of a burrito. Okay. A burrito costs the same amount as a taco. Good. Got it. Costs the same amount as a taco. So far. But then Patricia's like, we ain't gonna make no money if the tacos and burritos cost the same amount. So why don't we charge extra for the burrito? Like whatever the taco price is, let's just make it at $2.35 more. the beginning of a word problem. You miss this part, you can just stop on all the rest. Doesn't matter. Which is why I would give partial credit if you labeled the things on there. You made an attempt to put the first letter first equals some other junk. Half credit. That's how it all begins. Then the rest, let's see if we can get the rest. Let's see. Vanessa bought 4 burritos and a large taco for that amount of money. She bought 4 of these burritos plus how much? One. I'm gonna put 1 from that taco. All for $20.65. All right, take a look at it. And they started kissing. Oh, were they loving that kissing? No, they weren't. No, they weren't. They weren't kissing at all. They're tacos and burritos. How can they even kiss? Like if the tomatoes is touching all the avocado. All right, whatever. Here we go. So, with this speed, or if I do this, I'm gonna break my neck. I'm just gonna go ahead and you would have got where the word from. Let's see how much you was worth. Ooh, shoot, 4 points. But I give you 2 for labeling. 4 points, but I give you 2 for labeling. And a super one. 2 points and 2 points to grab. And another 4 points. Dang it. That's 8 points. 8 points. All right, here we go. Okay, you can work a total of no more than 19 hours each week between your 2 jobs. Babysitting pays that amount, and your sales job pays that amount. You need to earn that amount. All right, let's see if I can do this. I'm gonna break a rule by using the B and the S, which there's a lot of BS. I didn't even know that was gonna be available to me. Here it comes. Label will turn it into X's and Y's later on. Here you go. You can work a total of 2 jobs, whatever. Babysitting is one of them. B for baby. The other one is your sales job. S for sales. Looks like a 5, but I'm gonna make it an S. You can work a total of no more than 19 hours each week between 2 jobs. Okay, if I add my hours for babysitting plus my hours for my sales job, it says I can only do like 19 hours. I can't do more than 19 hours. Because I'm in school, I'm at options, can't do any extra work. How do you say you can't do any more than, no more than? You can either do 19 hours, or you can do less than that. But you can't do any more than that. That's how you get that there. Closing the door in my face, but whatever, 18 bucks an hour. I need to get at least 252 bucks. How do you write at least? I either need to get 252 bucks, that's equal, or more. It has to be at the least, at the very minimum, 252, or I need something greater than that, something bigger than that. So you need to know this idea of you're at least, and you're no more than. There are probably some other code words for, hey, when I use this guy, when I use that guy. But at least you got 2 of the codes, and I sure hope on the test they put the 2. They're on your examples. Let's pause it. 5, 2, 22. Here we go. All right, hey, a baker has 12 cups of flour and 8 cups of sugar on hand. He uses both flour and sugar. Those are the guys. Got it. You're an F. Technically, we don't like using S's because they look like 5s in the world of math. To change a 5, rather an S into an S and not a 5. We put these little tick marks on them. We do it for some other numbers, so that at least you will have seen it. A T, a 1, or a plus sign. A Z and a 2, you're a Z. A 0 and a 0, we don't use zeros. And O's, because there's no way to mark it. An S and a 5.
There's a way to mark the zeros.
No, I'm just saying we don't do it in the world of math. You could probably put that little thing inside, but yeah, my experience is like that or like that. Okay. Yeah, so I'd be surprised that you find any math book where they let the variable be a 0 or rather an O. Nonetheless, if I have an S He uses both flour and sugar to make cupcakes and cookies. A batch of cupcakes requires 4 cups of flour, while a batch of cookies requires 2 flours. Okay, I see some numbers bouncing out. A batch of cupcakes requires 1 cup of sugar, while a batch of cookies, requires 2 cups of sugar. Let X and Y the numbers. No, I'm not going to do that. Okay, X you're going to be for who? You're for the cupcakes, and the Y is for the cookies. I'm still going to use my original letters because they make sense. Later on, I'll change them to X and Y. But for now, let's see what I got. I got to read it one more time. First time is so you will have heard it. The second time is so that you know what to do, which is why math people, most of them, enough of them, are poor readers. We don't read novels. All right, here we go. I just downloaded a speed reading thing from a guy named Tim Ferriss. Let's see. A baker has 12 cups of flour, 8 cups of sugar. Got it. He uses both flour and sugar to make cupcakes. Got it. A batch of cupcakes requires 4 loaves and cookies 2. 4 and 2 is the first batch. A batch of cupcakes requires 1 and 2. Got that. Regular inequality that requires a cross combination of cookies that Tara can make. To make the ingredients on hand. Exactly. I'm gonna fight with this for 1 minute and then I'm gonna let it go. I'm gonna pause this because